Welcome to this closing session of our 8th Science Industry Roundtable on Eurocode 6. Having discussed in the former sessions the future of masonry, masonry mortar bond, formulation impact, and execution and quality control, we intend to start today the discussions of the national annexes. We will start with a presentation by Carolina Briceño from the University of Minho. She's doing her PhD currently over there. And she will tell us about the situation today in the national determined parameters in these national annexes of EN 1996 Part 1.1. We'll then have a Q&A session. Then the moderators of the 4 first sessions will give their takeaways, a summary of their takeaways of the sessions they moderated, followed by a final discussion on these sessions and a conclusion given by Richard Gibbons from EuLA as a representative of EuLA. Please remember that in order to actively discuss with us, you have to be connected in YouTube via an account, which can be your Google account. I'm looking really forward to today's discussions. We really hope that this will launch the further discussions in the national mirror groups. And I now hand over to Professor Paolo Lourenço from the University of Minho, who will be moderating this first part on the national annexes.
Okay, so good morning to all of you. It's a pleasure to be here again. So the work that Carolina will be presenting is somehow linked of the past work with now Dr. Mira Ramesh that finished the PhD recently, supported by the European Lime Association. So Carolina was also partly supported by EuLA for 1 year, and she has been working at the University of Minho since 2019. She's now doing a PhD supervised by Dr. Miguel Azenha and Dr. Graça Vasconcelos on multi-scale modeling with, let's say, focused on serviceability conditions, long-term behavior, and ultimate conditions to address the relevance of Lyme. So Carolina got, I think, the master degree at Pontifical University Catholic of Peru. A few years ago, she has been working in academia as a lecturer, and hopefully she will be finishing the PhD with us in about 2.5 years or so, 2 years. And so thank you very much to be here today, Carolina, and go ahead with your presentation.
Good morning to everyone, and thank you for the presentation. Today, I'm going to talk about the specification in national annexes, the national determined parameters of the Eurocode 6, Part 1.1. It is well known that the masonry is considered as an economical construction with a not complex building process. However, there are requirements and considerations that need to be fulfilled in order to ensure the structural safety and serviceability. In this way, the Eurocode 6 is the standard for the design of masonry structures, followed by the members of the European Committee for Standardization. It is composed by these 4 parts. In this presentation, I will focus in the first part of the first one, which is the general rules for masonry construction. In this standard, it is described the principles and the consideration for the structural safety, serviceability, and durability of masonry structures. As you see in this graph, this standard is composed by several chapters, as well as different sections of interest depending on the objective of the user. Besides, this standard provides the characteristic strength values, which are obtained from information related to the properties of the masonry components. The standard involves different types of masonry units made of clay, calcium silicate, aggregate concrete, among others, as well as 3 particular types of masonry mortars as the general purpose, thin layer, and lightweight mortar. In addition, each CEN member has its respectively national annex that includes the nationally determined parameters. These are values, classes, symbols, and alternative methods that are to be used in each country with application of the Eurocode, of the European codes. In this way, the main objective of this presentation is to show the influence of the masonry mortar within the considerations and recommendations for the design of masonry specified in the Eurocode 6, Part 1.1, in both versions, in the one of 1995 and 2018, as well as in the national annexes. In addition, there is a particular interest of the application of lime as a binder component in the combination of clay brick or dense aggregate concrete blocks in conjunction with general purpose mortar, because the high recurrence of these combinations in the European context. The national determined parameters are linked directly to specific chapters and sections of the Eurocode. In this case of the Eurocode 6 Part 1.1, those parameters related to the masonry mortar are the ones shown in the slide. Between these three groups is the second one who emphatically evidences the influence of mortar over the properties of the masonry. In this way, in the next slides, I will talk about those parameters related to the specification of masonry mortar, mechanical properties of masonry, and the formation properties of masonry. To start with the chapter of material specification of masonry mortar, in the 1995 version, it says that the mortar should be classified by mortar classes and described by their constituents in terms of cement, lime, and sand, and volume. It is also suggested that in the case of general purpose mortar, this may be designed or prescribed according to the standard 9982. And also it is indicated that each national annex should indicate the acceptable equivalent mixtures described by the proportion of the constituents. In a 2018 version, the same considerations are once again shown, in which the selection of the mortar classes or main proportions are not specified. If we consider all the information available in the national annexes, we see that basically the 32% of the countries, which are the countries in blue, are the ones that did not specify the mortar mix proportions in the national annexes. Meanwhile, the remaining 58 ones indicate the mortar class selection and also the mixed proportions. Regarding the mortar classes, in total, it was possible to identify 13 mortar classes, where the mortar class 2.5 and 5 were the most frequent in the national annexes. Also, in the Eurocode 6 Part 1.1, it recommends that those mortar classes indicated in the standard 9982, which are the ones shown in blue in this graph, are the ones that are recommended. However, we see that in the national annexes, there are additional ones as the ones shown here in gray. For the other hand, regarding to the mixed proportions, here in this table, I show all the mortar mixed proportion available in the national annexes. I would like to point out that even if two countries consider as acceptable the same mortar class, for instance, in the case of the Croatia, that is the first one, and for Greece, for the mortar class 2.5, even if they both select the same mortar class as acceptable, that doesn't mean that they will follow the same mortar mix proportion as you can see in the table. In general, the countries specify the type of line that is used in the standard. That is the case of Belgium, Luxembourg, Germany, Italy, Sweden, Portugal, and Cyprus. However, there are other countries that only indicate lime in the national annexes as lime without any particular definition. Going into detail regarding the mortar mix proportion, here I show the comparison between the absolute percentage of the components in a mixed mortar for the mortar class 2.5 divided by hydraulic lime, hydrogen lime, and also those proposals related to lime without any specification. We see that in the case for hydraulic lime, there is a good correlation between the radius of the mortar components, which doesn't happen in the case of hydrate and also for lime without any specification. On the other hand, in the case of the mortar class 5, now this good correlation happens for the hydraulic and also for hydrogen lime, but this doesn't happen in the case of the lime without any specification, and is super clear in the case of the Greek proposal against to the Romanian one. Considering the previous information, it was possible to propose the composition of masonry mortar, obtaining the table that is shown in this slide. In order to build this mortal mix proportion, we consider three particular points. The first one is that we assess the proposals without taking into account the distinction between the type of lime that is used. The second point is that we consider only those proposals whose variations were less than ±6% among them. And finally, with the auctions that are available after the two previous points, we consider the average of these components in order to have the values shown in this table. Continuing with the parameters, we have the parameters related to the chapter mechanical properties of masonry, the characteristic compressive strength of the masonry. According to the 1995 versions, there are two possible options to define this characteristic compressive strength. The method one is one based on experimental data. It is indicated that this data should be expressed considering the expression shown in this slide, where K is a constant that depends on the masonry units, groups, and material. Alpha and beta are constants. FB is the normalized mean compressive strength of the unit, and FM is the compressive strength of the mortar. The second method is based on the use of predetermined expressions, as the one shown here in this case for general purpose mortar. We see that the constant of alpha and beta have been replaced for the values of 0.7 and 0.3 respectively, as well as in the case of K, whose values are available in the standard. In the case of the 2018 version, the method one includes limitations in terms of the compression strength of the unit of the mortar, as well as coefficient of variation, and the geometrical properties or the grouping of the units. Meanwhile, in the case of the second method, these expressions remain the same. We see that the 95% of the countries indicate which of these methods should be used in their cases. Among them, there are 5 countries that consider both methods as acceptable. Meanwhile, there are other 15 that consider the first one and 9 that consider the second one. I would like to make an emphasis over the constant beta, which in the majority of the cases is 0.3. This constant beta affects directly the compressive strength of the mortar, which means that affects the participation of the mortar over the characteristic compressive strength of the masonry. In the majority of the cases, as I said, this value is 0.3, but there are countries like Belgium, Luxembourg, Finland, Austria, and also Netherlands that consider a decrease of the 17% for this value. And even in the case of Estonian, the value of beta is considered as 0. Here, I would like to show the compressive strength of the masonry in terms of the compressive strength of the unit. We see that the patterns are slightly the same. Only in this case, there are 3 graphs depending on the mortar class that is chosen. We see that in the case of the mortar class 2.5 and 5, the highest are the lower values of the compressive strength of the masonry, determined using the expressions available in the British and the Polish national annexes, are the ones with the highest and the lowest value corresponding. But in the case of the mortar class 10, the highest and the lowest values associated are the ones obtained considering the expression available in the standard. And also the lowest are the ones considering the expression available in the national annex of Belgium and Luxembourg. Another parameter that are discussed is the characteristic initial shear strength. According to the 1995 version as well as on the 2018 version, this strength could be determined based on the evaluation of a database of the result of the test or from the values given in the table. The 61% of the countries consider the table indicating the standard. Meanwhile, the 39% of the countries consider or propose a particular initial shear strength. However, the criteria and also the values are very similar to the ones shown in the standard, with some exception, as for instance, in the case of Norway, that the values are lower than the ones indicated in the standard. Other property that is of interest is the characteristic flexural strength. According to the 1995 version, this characteristic flexural strength could be determined based on tests or based on the values given in the table. It covers two different types of failure mechanisms. The first one, that is this one, corresponds to the out-of-plane bending parallel to the bend joints, and the second one, perpendicular to the bend joints. Basically, the version of 1995 and 2018 followed the same criteria and the same values, with the only exception for the masonry unit of clay and for mortar classes over 5 megapascal, which changed from 0.10 to 0.15. We see that the 52% of the countries consider the values given in the table. Meanwhile, the remaining ones consider other values, propose other values for the characteristic flexural strength, based mainly on the compressive strength of the mortar, the compressive strength of the unit, and on other features of the masonry unit. There are also parameters related to the deformation properties of masonry, in this case for the modulus of elasticity. According to the 1995 and also to the 2018 version, the short-term second modulus of elasticity should be determined based on the tests indicated in the standard 1052 part 1. However, in the absence of this short-term second modulus of the elasticity can be taken considering the expression shown here in the slide, where the value of the constant Ke is 1000. This value remains the same for both versions of the standard, and there is no additional criteria to determine this one. It also mentioned the long-term modulus of elasticity, which we see that is also based on the short-term modulus of elasticity. The 68% of the countries consider as 1000 for the value of Ke, but the remaining 32 propose a particular value, which in the majority of the cases is based on the compressive strength of the mortar or the brick. Finally, there are the parameters related to the deformation property of masonry, creep, moisture expansion or shrinkage, and thermal expansion. In the standard, in both versions, it is indicated that these values can be determined based on the result of tests without specifying any standard to be used, or could be taken considering the table showing the standard, which is the one shown in this slide. The 68% of the countries considering the ranges shown in the standard. Meanwhile, the remaining 32, instead of considering a range, they consider a fixed value regarding the constants associated to the final creep, the long-term moisture expansion, or the coefficient of thermal expansion. Finally, for the conclusions, considering the information in national annexes, we see that there are 7 additional mortar classes to the available in the standard 9982. Also, it was recognized that the most repeated classes were the mortar class 2.5 and 5, followed by the mortar class 10, 12, and 20. In general, but not always, the components of the mixed proportions in terms of absolute percentage were similar, varying less than 6% in the absolute volume of the total mix. Regarding the mechanical properties of masonry, the compressive strength of the mortar is an important influential parameter for these properties, according to the Eurocode 6 part 1.1 in both versions, as well as in the national annexes. Concerning to the limit values of the shear strength of masonry, Norway and Poland were the only countries that considered the compressive strength of mortar as one of the parameters. For the initial shear strength of the masonry, we see that it was mainly affected by the mortar class, while for the flexural strength of masonry in both directions, the values were influenced by the compressive strength of the mortar and for the unit material. Regarding the deformation properties of the masonry, like E modulus, final creep coefficient, moisture movement, and coefficient of thermal expansion, the influence of mortar was absent, with the exception of the case of Denmark and Norway. Finally, based on the previous information, it was possible to propose a mortal class selection as well as a mortal mixed proportions for the section 2 corresponding to the chapter materials on a specification of masonry, of mortar masonry composition. Thank you very much.
Okay, so thank you very much, Carolina, for keeping the time. We do have a question from the participants. I would probably just make a first comment before. As I think all of you know, we are in the process of completing the second generation of the Eurocodes. So we expect that all the Eurocodes are in its close to final version by 2023. The formal voting for Eurocode 1 will be happening now, so it is expected to start in September. And another Eurocode that is important for masonry is also Eurocode 8 in many countries. And this is expected to go to formal vote in 2024 only. As you also may know, so all the Eurocodes, the new ones that we call about the second generation, will have a date of publication of September 2027. So it's a little bit ahead. And the current Eurocodes will have as date of withdrawal March of 2028. So the present codes will be formally removed in a long time ahead still of 6 to 7 years. In any case, the good news is that part 1 of Eurocode will be voted this year, hopefully positively. And this means that the national annexes can start to be developed by next year, which will also certainly take a couple of years in most countries, not to say translations if they are to be made also to the national languages. So all this process is somewhat always long in Europe. In any case, as Carolina showed, there are many differences between the different national annexes in terms of performance, in terms of properties. I mean, some of the aspects which are maybe unexpected is the fact that natural hydraulic lime and standard, let's say, hydrated or aerial lime, not to be distinguished in many of the countries. And the question that Paul was making you, Carolina, and us is if you could understand from the national annexes that all mortars are actually used for structural systems. So M025 looks pretty low and in fact forbidden in many countries, not to say M05 or M1. And so in many countries, this would not be acceptable for application in structural masonry. So is there any hint in the national annexes where people want to use these mortars?
The only national annex that considered this mortar class of 0.25, in this case, was the case of Poland. Poland has the highest extension, as you can see. I don't know if you can see my slides.
Yeah.
Yes, it's the highest one. Who is the country that has the most extensive selection of mortar classes, including this mortar class of 0.25 and also 0.5 megapascals. It is not specified in this particular section of the national annex of Poland that this mortar should be used for the structural purposes. However, in the majority of these cases, this type of mortars are not used for that objective, but they are used, for instance, as a render, for instance, no?
Okay. And do you know about Sweden, which also has 0.5?
Sweden has also has 0.5, yes, but but technically, these are the only two countries that has a mortal class lower than the minimum suggested by the Eurocode. Because in the Eurocode, and they say that you should consider only those ones indicated in the standard 9982 part 2, which the minimum corresponds to the mortal class 1.
Okay, and so we do have, sorry to interrupt you, yeah. We should have representatives from Poland in the session, and maybe Sweden, I'm not sure. If they would like to comment something in YouTube, it will be there for other people having this concern, and we can also comment if we see it in YouTube. So I'll give a few seconds if they would like to add something to YouTube. Otherwise, we would go for the next roundtable, if you agree, or the panel session. I don't know if you want to comment something in addition, Carolina.
Regarding this, no, I will say that in general, the national annexes of each country should consider at least as a boundary limits the ones indicated in the standard 9982, which are the ones recommended by them. Those outside these ranges should not be recommended to be used, probably.
Excellent. I see no remarks in YouTube. They may be added later on. And so I suggest that we move to the panel session. So the panel session will be held by me, by Dr. Miguel Azenha and Dr. Ulrike Peter. And we will try to revise what was done in the different sessions we had to prepare this final session. And so I will be the one starting, and I will try to review briefly what was done in session 0 and session 1. And so session 0 was opening, let's say the discussion, and we had, as you can see, basically, I gave a presentation on some possible vision of what the future of masonry could be, what are the needs, what are the developments, and some view on what is coming in the new Eurocode that again will be subjected to voting still this year. Then we had a panel with representatives of the industry, Rob van der Plam for Wienerberger, Antonio Caballero Gonzalez from the European Calcium Silicate Units Producers Association and Europe Mortar Association, and Joachim Rietjes from the German Association of Insulation Systems, Plaster and Mortar, and Cliff Fudge from AAC Association. So basically, I tried to sum up in a very fast way what the panel stated. And so this is, let's say, a short glimpse of 1.5 hour or 2 hours discussion. And so the understanding was consensual that masonry design and masonry practice, meaning materials, building technologies, meaning also conception of structural systems, will remain quite different around the world and will remain quite different around Europe. And so it is a must that European normative is able to allow all these solutions, materials, technologies to be used and to be covered by the codes. We also, because there is a lot of competition, we are all aware with different building products, and politicians often refer to the building sector because being quite intensive with environmental impact and use of natural resources, we need to build on the strength of the products. So there are many important aspects related to masonry products, either related to energy consumption, to the use of local raw materials, to the availability and the need to use local manpower and creating employment. So there are many potential benefits of the products, durability, strength, fire resistant, etc., that we need to build, that we need to show their strength. As it is in the second point, masonry construction still remains widely used. It's very simple in technology. Obviously, there are many competing new technologies that make it different from the past, but faces challenges. And so some of the challenges that were particularly identified is earthquakes, because most of Europe is unreinforced masonry, and unreinforced masonry has limitations in moderate to high seismicity zones, and all the issues related with sustainability. This includes aspects, obviously, like CO2 emissions. This includes aspects like construction and demolition, waste and reuse and recycle. This includes efficient use of raw materials, etc. There were also many aspects related to innovation, both needs and recent developments. One of the key issues is building information modeling. So the digital transformation in the sector is a need. BIM remains a true challenge, and it becomes, well, it is even a more important challenge because of diversity of masonry. And so this is something that is more difficult than for other building materials, because if the materials are quite different, the building technologies, this poses challenges in having all this pre-installed in international databases that allow ease of use in BIM. The other aspects that were addressed, also related with digitalization, was the Smart City brand and the need to be sure that we are able to produce, to monitor the use, and to mark correctly the masonry products so that they can be easier controlled and installed. Many new materials were presented and addressed, including the extensive use of dry mix mortars, the use, for example, of mortar pads in Germany to build faster, the use of very large size blocks with semi or partial automation to reduce the cost of manpower, the evident need of addressing carefully energy efficiency, because this is a must with directives from the European Commission and so, or European Union. And so there are many challenges that we need to bring into the masonry sector. The final aspect that I would like to present as a conclusion of the first session was the important aspect of manpower. And so this is a problem in Europe because more and more people do not want to work on manual jobs. And so the need to import manpower and the shortage of manpower in many European countries to work as masons. And so this is a true challenge because the type of traditional construction is somewhat labor intensive. And that's why in so many countries there are changes to reduce the amount of labor. So cost of manpower is also an issue because it affects the cost of the building technology. And there is huge competition with off-site manufacturing. And so today, of course, if maybe 3D printing of a full building or a full house is not the future, but is certainly the future of site manufacture with, for example, walls or bathrooms or kitchen being fully built outside and being transferred with all the building services inside. And this can also pose these changes to masonry because of many reasons, such as weight, such as ease of building, etc., in a plant. So this is briefly my understanding of what was most relevant in session 0 as introduction. I will go to session 1. Again, after this presentation of the 4 sessions, we'll have a panel and round discussion to discuss questions that may be arising from participants. So session 1 was about masonry bond and on mortar. And we have 3 participants. So one is Paul Christiansen from Denmark, the other Rovan de Plaun from Wienerberger, and the other Miguel Azenha from my university. And again, I tried to merge the comments and the most consensual or most relevant comments I understood from the participants. So there is a strong agreement that the bond strength is essential for masonry performance. And so this defines masonry performance, particularly in serviceability conditions, but also in ultimate conditions. And this involves basically 2 important mechanical parameters. One is shear and the other is flexural strength, okay? Now, some countries do not recognize flexural strength for masonry joints because, as you understand, flexural strength is based on tensile strength, and so some countries do not recognize it. Some countries also assume, and if I understood well, Denmark and the Netherlands assume the same value for both. In fact, they are both based to the same process, which is the chemical bond, or if you want, aspects like the fines entering the pores of the unit. And so they are related to the same physical or chemical process. It was also stated that they are very highly dependent on the initial suction rate of the units. This is capital for clay brick units, and they should be less than 2 kilos per square meter per minute. Or if this is not the case, you have to be very careful in properly pre-wetting the unit, okay? And we know this might be a problem on the job site because of many reasons, including lack of control or lack of will of the worker, okay? Then it was also stated, which is well known, that bond performance is highly dependent on mixtures, admixtures. And this is solved by the new code, the new masonry code, because the current masonry code says basically you can only use the tables provided if there are no additives or admixtures. And this is impossible almost, because the admixtures are in already mixed mortars, and additives, I believe, are in most cements anyway. And so this is a true problem. The new version of the code says that the values in the code are only valid for site-made mortars that do not contain admixtures. And so hopefully it will solve the problem to some extent. Now, we also know that there is weak correlation between mortar strength, compressive strength, and bond strength. And so this was clearly stated that the 2 parameters are not directly linked, and there are many parameters that influence bond strength. And these are related to things like the unit, properties, the mortar composition itself, and the interaction of both, and also the execution. And so, I'm sorry, it seems that it's not very easy to understand and establish parameters to define bond strength because it depends on too many aspects. It was stated also that the local experience in a given country, for example, is quite important. And it was discussed on who is the responsibility to ensure this strength. I'm sorry. In the Netherlands, they made it clear that responsibility is for the contractor. And so it's not the liability of the mortar producer, or a unit producer, it is the contractor that has to issue. And finally, in case of testing program, I'm sorry, the benefit of using lime was not very evident in the bond strength. And one of the issues is that perfect execution conditions were carried out in the testing program carried out at University of Minho. And this may not replicate directly the conditions in the job site. Okay, so thank you very much, and I move to Ulrika.
I'm sorry, I have some problem. Can you please confirm that you hear me? Okay. Please give me 1 second to solve this. Well, I will not be able to solve this, but as I heard you hear me and you see my presentation, I will go on now. I had the pleasure to moderate special session 2, which was on the formulation impact. And there were 2 presenters over there presenting PhD works. The first one was at that time engineer Mira Ramesh, who today is a doctor, who presented her PhD work on a multi-scale approach to the study of lime cement mortars in masonry. And the second one was another PhD work by Stella Macaria on the creep mechanisms in cement and lime mortared masonry. These 2 works have been chosen and proposed because they represent a thorough quantitative assessment of trends in mechanical strength, as well in mortar and in masonry, as a function of the lime content in the lime cement mortar. Very often there is a huge literature on lime cement mortars. There is a huge literature on lime cement masonry. Very often you cannot correlate because not everything is very well defined. For example, compositions, etc. Here in these 2 works, there is really a thorough description of the type of mortar which is chosen, of the conditions of performing tests that was noticed by Paulo Lourenço just in session 1. Maybe sometimes we thought that the experiments might have carried out even too perfectly. But here we know, here the conditions, the compositions and the conditions are very well described and should allow for a correlation of the mortar performance and the masonry performance. What has been shown in these 2 presentations is that the mortar compressive strength only has a minor impact on the compressive strength of the masonry. I think that this was already known before. And it was shown that the average wall compressive strength is higher than the mortar strength in average. And in the case of the weakest mortars, it is up to a factor 10 higher than the compressive strength of the lime-containing mortar. It is also shown that addition of lime decreases the compressive strength in both the mortar and the masonry, but it also allows for an increased strain capacity of the masonry. As observed in the PhD of Mira Ramesh, on 1 brick time, masonry flexural strength seems to depend on the mortar compressive strength. This has been shown there. And there is a direct correlation with the mortar compressive strength, and for sure that the mortar compressive strength is varying as a function of the lime content, but the impact of the lime quantity could not be evidenced other than via the compressive strength. However, when varying the brick type in the PhD of Stella Macaria, the flexural strength decrease does not follow the compressive strength exactly of the mortar. And it has been stated also in session 1, just mentioned by Paolo, that it depends that it is known that bond depends on other factors, such as water absorption or water retention of the mortar. And it has been stated that very often we observe a water shortage in a mortar, which for sure was not given here in these works, which were undertaken in ideal conditions. It was shown that the lime content has a direct proportional influence on the early creep rates of the masonry, and in any case studied, the creep leveled out as a function of time. Both works have been performed in order to be compared with Eurocode 6, and the work of Mira Ramesh allowed for comparison of the compressive and the flexural strength with the Eurocodes. It shows that Eurocode 6 currently overestimate the compressive strength and underestimate the flexural strength. With respect to creep strains, it has been shown in the work of Stella Macaria that the recommended creep coefficient values predicting the 60 years creep strains, for the higher lime containing mortars are validated as they are described in Eurocode 6. And it has been discussed here in this work that for sure that what was not discussed in these two PhD theses, potential other advantages of using lime in a mortar would be better workability, better water retention, or also the eventuality of more robust formulations. And this is not studied in these two PhDs. Thank you very much.
So I will get on with the presentation. Miguel Azenha, it is my pleasure. It has been my pleasure to moderate session 3 on masonry execution and quality control, and it had participation. The panel had participation of Andrew Smith from Forterra, Franz Loderer from Xella, and Udo Meyer, Ziegel. And they delivered 3 very interesting presentations, and I'll try to summarize in a brief summary in a brief information what they actually presented, and then the interesting discussion that happened afterwards. So the outcomes would be a first point, which was made in the initial presentation. Standards are really important in the market because we need to ensure predictability. So not only the producers need to communicate what they are doing, and the end users need to know what they can expect from the products. However, in the case of masonry systems, which are complex and perform in situ, in the location, it's not possible to create a declaration of performance such as you do for a finished product that comes directly from a factory. So in that sense, this becomes a much harder task to normalize and to standardize, also taking into account the third aspect I mentioned in this slide, which is the strong dependence of workmanship quality, which has been raised in the previous sessions as well. And unfortunately, the workmanship frequently skips instructions. And this is one of the challenges that we have when standardizing, because instructions must be simple and then ambiguous, because the risk of not being followed gets increased exponentially when we start getting more complex and if ambiguity comes by. So another aspect that was really stressed in a very strong manner during the discussions was the fact that there's an extreme diversity of cultures and ways of building and original materials in the different countries around Europe. And this causes that inherently it's unavoidable that different practices will happen, and let's not try to standardize what is non-standardizable. So then the national annexes will come as a very strong tool to make the markets or to make the standards adapted to local situations. There was a discussion also, and this was on the second panel, panelist Franz Loderer, about the new revision of the Eurocode 6 Part 2 on the design considerations, selection of materials and execution of masonry. So Franz has presented several aspects of high importance of what's being done on this new revision and several aspects that are innovative. And of course, I'm supposed here to raise your curiosity to see the session in case you didn't see it. And he discussed several aspects regarding particularly protection against rain, freeze thaw, on a very interesting further aspect on the micro conditions in masonry. So for example, the rain will not hit the masonry in the same places according to the location in the building and to certain constructive aspects. And also there was a part of the presentation dedicated to acceptable specifications for durability and many others. So there was a disclosure of what is to be expected also as novelties in this new revision of the Eurocode. However, again, as I stressed before, and sorry, there is a little bit of repetition here, but it's really important that there are many country-dependent contexts, and we need to go for further documentation in many situations. And examples were given and discussed. For example, in the case of freeze thaw, Germany has very detailed national annexes for the purpose. The British standards for workmanship and some standards specific for masonry construction exist, and they provide also national context with taking into account culture, materials, and climate conditions, for example. And finally, and not least important, the guidance that can be given by manufacturers and associations that are produced for really specific contexts. One has to take into account that when there is a specific type of construction, the standard needs to be generic by definition, because it needs to cover all situations possible. But when a manufacturer is providing guidance on the application of a product, this manufacturer or even this association of a group of manufacturers are being extremely specific on the application of this product in certain contexts. So they could even be driven by national demands according to what happens in each situation. And also standards need to unite consensus of groups of people. Even the national annexes require consensus. And many times consensus is hard to come by, and manufacturers and associations are more likely to produce very detailed documents that produce more detailed information for application. So one should never forget this level that is not at the level of standard, but can assist very much. And this was covered in the discussion as well. So going on, the last presentation and the discussion by Udo Meyer, he raised several aspects regarding the thin layer mortars. He discussed the very predominant place in the market of this type of application of mortar. He discussed the very big importance of the first layer and its quality, and the application processes, not only of the first layer, but of the others, and the cleaning, and particularly the thickness measuring, which is a measure of the quality control of what has been built. And even though thickness might seem as a very simple thing to measure, it turns out that it's not that simple in practice, and this can be something that can be problematic when contractual accomplishments are being inferred, and if a problem happens. So we need to be able to check how things were done, and there should be precise instructions on how this can be done and how this should be committed into a document. So this was something that was clearly stated as important. So finally, and speaking about the future, and particularly regarding the fact that we are creating this new version of the Eurocode 6, and there will be national annexes to complement it, there were some statements that I think are pretty much summarizing an agreement that was within the panel. So first, that we should try as much as possible to be outcome driven in the assessment and prescriptions, rather than only focusing on the process. It doesn't mean the process is not important. Of course, we have to define the processes to get some outcomes, but in the end, we need to assess what was the outcome. Does it satisfy what we needed or not? So this performance-based system is not currently on effect, and this is something the future should consider. Then again, the relevance of regional contexts, we need to cherish them, and we don't want to homogenize them. This has been very much re-stressed. Again, another aspect which was really important also in the discussion was the need to promote the engagement of all stakeholders. So contractors and masons, people that are actually in practice and normally may not be going to these committees, the mirror committees that are making national annexes, and then they will complain this regulation does not match my expectation. This capacity of engagement is really important, and they need to be involved since the beginning. So this is one of the important challenges: involve as much as possible. Each country drafting national annexes should involve their stakeholders as much as possible. This is a hard one, but it needs to be considered very carefully. And then it was raised that some requirements that are currently on the codes may be too strict or too conservative. The examples of joint thickness and bond strength have been forwarded. This is something also that should stay for consideration. And finally, two aspects that are not considered in the current generation of Eurocode, circularity and robotization, definitely need to come into account. Robotization is more of a thing of the future, not too far, but the future. Circularity is something that should be taken care in the very near future, given the importance of this context in the world. Finally, sorry for the very Spider-Man figure, but we have a great power with the national annexes and the Eurocodes, but we do also have a great responsibility to make this work and to make this work with the lessons learned from before. So as Paulo Lourenço said before, we have the date of publication for the second generation of Eurocodes up to 2027. So the Eurocode 6 is really well advanced in regard to that, which is good. Particularly in part 2 of Eurocode 6, the voting is not next year, but in 2023. So it's expected also to be ready relatively soon. And definitely this is the challenge here, and all these sessions were devoted to that, that the national mirror committees start working very carefully on this and learning from past lessons. And particularly the presentation by Carolina was a really eye-opening situation for the differences between different countries, and maybe we should be looking at how these countries are addressing the problems and maybe take some lessons from each other. And yeah, that's it. Thank you very much.
Okay, so we are now opening the YouTube to some interaction. If you'd like to make any questions, I think, we concluded in a nice way by Miguel, in the sense that now it's time to gather the information available and do our best in being sure that the national annexes reflect the condition in each country. Obviously, that the national annexes are easier to change than the Eurocodes, because we are seeing that we are looking for about 20 years framework or 25 years to revise let's say the European standards. That seems to be quite long in comparison with other countries, for example, in the US. And so we probably need to do something in general, but this is not the place to discuss it. So one question that we have, or one comment, is from Andrew Smith. Thank you, Andrew. And basically is addressing the manpower and how do we link our knowledge from lab and from code drafting to execution, and how are we able to ensure that we reward the manpower adequately and we have highly skilled people in doing the job. And so this is not something which is easy to address. I would invite the other members of the panel to comment.
If I may, Paulo, it's really hard to address. I think this is a societal perception of the value of the work of people. And I make an analogy with a reality I know really well, particularly in my country, in Portugal, that, for example, in the structural design community, the values that people are getting paid seem to be getting lower and lower. And because the perception of value of society seems to be decreasing on that. So some work on the image of the importance of what's being done in masonry, such as the example I was giving in design, I think it's a part of the education of the society, because we will not get there with politics or something like that. I think it's perception of society, and then the value of things will increase. But this is highly subjective and highly speculative, but I just raised my opinion. Thank you.
You mentioned the education of society. So maybe there is a share for education, universities, trainings, etc.
Definitely.
So maybe a question that I would like to put to the panel, which I liked very much let's say, on the summary of Miguel, is the engagement, because this is the next step. And so, good or bad, take into consideration what was possible, and in a pragmatic way, the new version is now in vote. And so we expect it to be approved after all the discussion with the different, let's say, narrow commission, mirror panels and national contact points. And so now the next step is indeed the national annexes. The question is, what can we do? Because I understand there are participants also here from the mirror committees. What can we do to be sure we engage the society? And when I mean the society, is the designers, architects, engineers, the producers of materials, mortars, lime units, and the people executing. Because in fact, normally the time goes faster today that used to go 50 or 100 years ago, and everybody complains they don't have time. But then everybody complains that what the others do is not okay. And so how can we be sure we engage the relevant stakeholders? And this is a challenge for everybody now. The moment is now.
So Ulrike, if you don't take it, I'll start. So Paulo, I really think that in this situation of involvement of stakeholders that normally would not adhere to this kind of situation, so that, for example, a small or medium company that will have a lot to say about the practical application of things, but they do not have the resources or the departments to work on research and development or even contribute to normalization. I would say that probably we would benefit from one of the few good things that we got from all this pandemic. Everyone is a little bit more available to get online information and to participate in a remote manner, and maybe we cut costs. And these kind of webinars that we are doing, probably I would imagine that the committee drafting the national annex in a given country would just go through a process of I would not call it marketing, but I would call it a communication to the community, and try to provide an opportunity for them to influence. But I think that probably this should happen after something has been drafted and very concrete information exists, or else if we just raise the discussion, what do you think this should be? I think we'll just get a very big pile of discussion with no end, because everyone has an opinion. So yeah, I would think that I would take on events to make it be disseminated, and then figure out a way to come up with responses, either collected online or collected even in a physical event, which I hope can happen. Yeah.
Hey, Ulrich, I don't know if you have any comments. Otherwise, I think we can move to Richard for conclusions.
Yeah, I think we can move to Richard for the conclusions, as by EuLA.
Hello. Firstly, on behalf of the EuLA Building Materials Task Force, sincere thanks to all the speakers, moderators, and the other contributors for the interesting and informative presentations and discussions during this series of science industry roundtable events. We've just heard Carolina's study of national annex recommendations and summaries of the previous sessions, during which we learned much, and we have been given very much to consider. So in conclusion, a few remarks. Of course, the overall aim of all that we have been discussing is to find the best route to good quality durable masonry. The evidence of our experience and observations is that incorporating a substantial proportion of lime into the binder content of a mortar or render or a plaster material in masonry is beneficial to the overall performance of the masonry and the long-term durability of the building fabric. And in our current drive for sustainability and reduced carbon footprint of construction, the use of lime in masonry mortars can offer benefits regarding robustness, carbon capture, and potential recycle options for the masonry materials. But much scientific work and extensive research has been carried out on mortars and masonry by academic and industry bodies over many, many years, including significant input on behalf of EuLA, and EuLA continues to support such work, as you have been hearing. And it's aimed at pursuing the promotion, or more correctly, the revival of the use of lime in mortars in the interests of good durability and performance of the masonry. However, our aim has encountered major obstacles, and some of which have been highlighted here in the sessions looking at requirements and specifications and testing. It seems clear that the current system of codes and standards generally considers individual components of masonry systems, and furthermore caters for test methods which basically give numerical results based on simple mechanical strength, usually compressive strength, and also in idealized conditions. And these numbers can then be used in standard forms of calculation. The tests themselves are mostly derived from tests for concrete, which of course is used in different ways and in very different systems to masonry. So national annexes to design and material specifications provide a certain amount of guidance on mortar characteristics. However, as we have heard this morning, there are wide variations between the various recommendations. For example, an M5 cement lime sand mortar, it would seem that Romania suggests a lime component 10 times smaller by volume than the proportion suggested by Greece. Although, as Miguel pointed out, we need to cherish regional contexts, there is clearly here a need for some wider agreement, and perhaps this should be an early topic for further discussion in the future. And of course, there's also the issue that whether in national annexes or basic material standards, there is generally no actual requirement to include lime at all in masonry mortars. and it is easier and undeniably cheaper to achieve the required compressive strength without the use of lime. But the benefits of lime seem evident from our observation and our experience. Lime-based mortars have been used in masonry construction since the earliest of antiquity, for thousands of years. The durability of masonry using lime or lime-based mortars is amply shown by countless buildings worldwide, and particularly here in Europe. Compared to the millennia since those times and the centuries of experience using lime-based mortars in the modern age, in Europe and elsewhere, we've only seen a couple of generations, in fact, where the predominant trend in masonry mortars, including renders, has been for brittle, high-strength, fully hydraulic binders without using lime. And in this short time, we've observed an increase in many problems, such as macro cracking, water penetration, debonding, efflorescence, erosion of masonry units, and other issues with such buildings. And our tests and standards using the results of such tests inevitably do not favor the adoption of a more ductile, porous characteristic of materials, such as exhibited by lime-based mortars. It seems to me that we simply do not have accepted methods of testing for the properties which would demonstrate the benefits of lime-rich mortar formulations to good quality, long-lasting masonry. So in conclusion of these interesting and informative sessions, I think I can say that they have in some ways served to highlight the limitations of our approaches to testing and to standards. How do we assess or test mortars and masonry for properties such as durability and tolerance to the very great variations in workmanship and conditions on site? I think our challenge for the future is how to address this. How can we demonstrate what we all know to be true, but it seems we can't prove by current methods? Thank you again to all our speakers, moderators, and of course, those who've been interested to log into our sessions over the last few months. Let us look forward to more valuable and interesting discussions in the future. Until then, thank you once more, and goodbye for now.